Dear all, in this session, we will discuss about different aspects of IoT programming for real world applications in context of lightweight protocols and flow based programming. Nowadays, you might have seen that almost everybody is using some particular AI based tool, some AI based platform. Okay, and along with that specific AI, we are integrating IoT. Okay, so nowadays, multiple technologies are integrated. If we are discussing about IoT, then artificial intelligence is also integrated. So we will discuss about that particular part also, how to work on IoT and AI integration for lightweight protocols with use of flow-based programming. Okay. So as far as current scenario is concerned, you might have seen that we are making use of different IoT gadgets, different sensor-based devices. Few very commonly used sensor-based devices or wireless-based devices are smartphones. You might have seen that Amazon Fire Stick is available, Amazon Alexa. So many handheld devices, smart watches are available. Along with smart watches, you might have seen that so many people are using health gadgets. So all of these are technology integrated in which IoT is there, sensor based communication, satellite based communication, and for data analytics, for prediction, for evaluation, AI is also there, AI and data evaluation part. So if we want to work with these scenarios, we want to work on these type of applications, then which protocols are used? For as all of you are teachers, all of you are academicians, you might be working on different research projects. Many times we apply for project fundings or to guide our students, we work with some sensor based scenarios. So if we want to develop such implementations, then which protocols are available, which options we are having nowadays. So you can see few names I have mentioned in this slide, very first slide, that is, so some of the very prominent platforms, very prominent protocols are MQTT, that is message queuing telemetry transport, constraint application protocol, lightweight machine to machine protocol, AMQP is also there. So these are the key protocols which are used in IoT programming, sensor based programming for real world communication. You might have seen that nowadays in vehicles we are using FASTag. So that particular scenario is also an example of real time communication, real time collaboration with some particular gadgets with some specific sensors. Okay, so as far as FASTag is concerned, a very small size chip, very small size uh, chip is communicating with sensors. As soon as it is coming near or it is coming in range of some particular server or base station, at that particular time transaction is performed. So many implementation aspects available in military operations also. You might have seen that nowadays IoT enabled smart drones are available. Okay, so in many instances you might have seen nowadays, to avoid human loss or to avoid loss of human life. Okay, so many drone applications are used in military operations, in strategic operations, whether we want to use these drones for defense or for law enforcement. Okay, if we move back to 5 to 10 years, in that case you might have seen that uh, it was very rigorous training for human pilots, but that is also associated with so much resources. But nowadays, as far as drone applications are concerned, so any number of drones can be deployed, and by remote uh, placement at some particular remote base station, we can control these drones, and obviously it will be more accurate, okay, more focused, and no loss of human life. Okay, so these are some implementation aspects. So on these research projects we can work. You can propose to some funding agencies, you can work on some realistic research projects. Okay, so first of all, before covering some implementations, some demonstrations, we are discussing about some use cases. Okay, first of all, we are discussing about use cases of IoT scenarios, IoT protocols. So in this particular scenario also, IoT protocols are required. Okay, now for controlling or to communicate with IoT based drones, which protocols are used? Okay, so MQTT, AMQP, COAP. If we want to work with smart home automation, in smart home automation also we have to work with MQTT protocol. So I will show you some demonstrations to whatever level it is possible in an online session. Okay, uh, with some, with use of some particular simulators, with some cloud based platforms, I will show you the demonstrations. Okay, but before that we are discussing about the use cases. So you can see that IoT AI enabled robots for military, strategic, and defense operations. So again, same point, most of the defense establishments, they have already deployed smart dogs, okay, or IoT based gadgets. Okay, rather than moving physical army or human based army, in many countries who are already equipped with technology, who are already making use of IoT, AI, and sensor based technologies, they are making use of these robots. Okay, so uh, we can work with such scenarios, and not only for defense applications or law enforcement applications. You might have seen in entertainment sector also, in sports also, such type of devices are available. In IPL matches you might have seen a dog that moves around a particular stadium, a particular land, and keep track of each and every activity. Okay, so it's up to that particular use case or objective for which purpose we want to deploy. Okay, for defense for defense, for strategic operations, for intrusion detection, or for entertainment, for sports activities. Okay, so in this way, defense robots to carry some particular casualties. If there are some casualties in some specific land, in some specific location, then rather than human being, we can deploy such applications, IoT based applications. Okay, but major part is that if we want to control these devices, for example, some devices we have developed, some IoT AI based gadgets, these are already deployed. How to control, how to communicate with these gadgets, how to communicate with these type of devices. So for such type of implementation, for communication with remote gadgets, whether these are small scale or large scale, small size or large size, we need very lightweight protocol. Okay, very lightweight protocol, and in minimum resources we will be able to work, okay, without need of full-fledged satellites. Okay, in same way, for smart home automation, rather than so in parallel or in alternate to strategic operations, in smart home, smart office automation, you might have seen IoT scenarios are very very popular. Okay, for example, from our mobile phone, Android or iPhone based smart gadget, we want to control all home appliances, washing machine, refrigerator, AC, or LED, whatever it is. Okay, or your vehicles. So n number of devices and number of gadgets we want to control from a common dashboard. So if we want to create this type of dashboard, then lots of platforms available, lots of toolkits available in free and open source distribution. Okay, I will show you those applications. and how to use those applications for smart home automation, smart office automation, or to control some devices. For example, you want to control your home appliances, some gadgets from your mobile phone, that can be done. Okay, and for these type of applications we need very lightweight protocols. MQTT is there, COAP is there, and lots of other protocols. Okay, in same way, drones with computer vision for law enforcement. So all of these applications, all of these deployment perspectives are very very realistic, and lots of agencies are working on it. Real time number plate detection, real time movement detection, human movement detection. You might have seen at the time of lockdown or curfew, these type of implementations are done by law enforcement agencies, okay, for by civil defense agencies, so that any human movement or any suspicious movement can be detected on different traffic lights, on different traffic crossroads. You might have seen real time number plate detection is there for challan system. Okay, so if some particular offenders are there, okay, low offenders, so to identify those offenders and then to capture their details, to capture their biometric, okay, whosoever is sitting in on driver seat, and what about their number plate recognition. So all of these deployments are related to IoT, but along with IoT, we have to integrate data science, data analytics, artificial intelligence, so that dynamic recognition of objects can be done in this way. You might have seen vehicle and number plate detection. These scenarios are very very popular in, specifically in metro cities. These are already deployed. Okay, in metro cities, in tier 1 cities, these are already available. Whosoever is the offender or n number of people, they are breaking some particular law and order, that can be detected from number plate or by human biometric face recognition. Everybody's face is associated with biometric details, and that biometric detail is available with Aadhaar card. And with Aadhaar, you might have seen that so many details are linked. So, so from somebody's face only, each and everything can be identified. So these projects, these deployments are very very popular nowadays in IoT, AI, data analytics, and for these deployments we need very specialized protocols in agriculture sector. Okay, not only for defense or smart home automation or number plate detection, so many applications in multiple domains. Intelligent applications for agriculture. For example, we are working on a research project for plant growth detection, okay, or disease detection or fungal infection detection in some particular crop or in some particular plant. So with webcam that is attached on drones or at some particular locations, agribots, we can call these as agribots, agriculture robots. So they will identify the land parameters, plant parameters. Okay, so different environmental factors are identified, and once these factors are evaluated, then suitable action can be taken, preventive measure can be taken by the farmers or agriculture scientists. Okay, in same way, industrial automation, smart ambulances, 5G powered medical robots. Okay, so many applications available, so many things. We are surrounded nowadays with multiple IoT based gadgets which are integrated with advanced wireless embedded technologies and AI based modules. Okay, whether these are smart health gadgets, smart watches, or smart parking system. You might have seen in many vehicles, in many high-end cars, smart parking is already integrated. So a virtual rectangle is created. For example, we want to park a particular car in a specific location. So a virtual rectangle is created. So we can detect whether our vehicle will be fit in this particular area or not, rather than hit and trial. Okay, so all of these are integrated with data analytics, with embedded systems, with IoT. Okay, and along and beside these, for smart home automation, you might have seen that Amazon Alexa is available. That Amazon Alexa device we can link with different gadgets, with different appliances, different home or office appliances, and then we will be able to communicate with them. Okay, now we will see, if we want to work with these applications, if our research work or project work is associated with these type of scenarios, then which programming platforms we have to work with. Okay, now we will see those platforms. Okay, now we will discuss about that particular part, very focused to IoT protocols in IoT. And if we want to work with these applications, for example, smart home, smart watch, or we want to control our home appliances with our mobile phone, then how to do it? This is known as sensor interfacing part, or communication with our devices, with our gadgets. To work with sensor interfacing, to work with IoT based implementations, there are lots of toolkits available which we can use for real world implementations, or at least for simulation. For, if I want to work with smart home automation, in that case, which programming language or which programming platform we have to use? Okay, first of all, we will discuss about the base protocol and how to integrate that protocol or that toolkit in our system. So you can see that in this particular slide, one board is there, Raspberry Pi, Arduino board, any board can be there. If this particular board we want to connect with multiple devices, for with multiple sensors, for example, humidity sensor, we have some temperature sensor, or any other type of sensor, we can link with it. But by which protocol this particular interfacing will be done, using which protocol we will be able to communicate remotely with these sensors? I want to communicate with these sensors or with these gadgets remotely. So for such type of implementations, for these type of applications, we work with very specialized protocol that is known as MQTT protocol, and this protocol we will cover in this session with live demonstration. Okay, for example, we are working on some environment for uh, hospital management. Okay, some particular body parameter we want to capture from patient, and those body parameters we want to analyze and visualize on a mobile phone, on some gadget. In that case, what we will do, so different sensors are attached with a particular board, and with MQTT protocol, message queuing, telemetry transport, we will be able to interface with it, we will be able to communicate with it. So officer in charge, or medical expert, or administrative officer, they will be able to communicate with IoT protocol. Why we are focusing on IoT protocol explicitly? Because when we communicate with low powered or low resource devices, you might have seen, in case of IoT, we we work with low powered, low resource devices. These are low resource devices, for example, some humidity sensor, some temperature sensor, some very small LED. Okay, so in very small size, chip size device, we can't install a complete software, for example, a SIM card. okay, or fastag. What is fastag? Fastag is only very small size chip, okay, similar to sim card. So I want to communicate with a sim card, I want to communicate with a particular device without integrating it in a particular phone. As far as sim card is concerned, we put that card in mobile phone, but you might have seen FASTag is not attached with mobile phone. FASTag is placed on windshield of car, okay, on front wind panel or wind glass, whatever we call it as, okay. In in front we place that particular chip, and as soon as we come near to the toll plaza or we come near to that particular server, then transaction takes place. So you can see that in that particular chip independently communicating with that particular server or with that particular base station. That chip is independent, it is not installed, it is not integrated in a mobile phone. It is only, we have pasted it on car. Still it is communicating. By which way it is communicating? Using very lightweight protocol. So multiple applications, multiple options we have for implementation of such type of scenarios, okay. So you can see that now we will discuss about that particular scenario, by which way we will be able to work with the device interfacing. If you have Amazon Alexa or smartwatch, and with that particular smartwatch or Amazon Alexa device or with your home appliances we want to communicate, then with MQTT how to perform interfacing, or by COAP, constraint application protocol, lightweight machine to machine protocol, or advanced message queuing protocol, how to do it. So in this case what we do, we install a particular software that is known as MQTT broker, okay. Now first of all we will discuss about the problem statement, problem definition, what we are discussing here. For example, I want to work with smart home automation. I want to control my home appliances with my mobile phone. In that case, what I will do? I will download MQTT software that is providing MQTT protocol that is integrated with MQTT features. Okay, MQTT software we will download. It is available free and in free and open source distribution on multiple platforms. Okay, I'm showing you so that you will be able to work with it. So MQTT Mosquito. Is this visible to all participants? Kindly confirm. Is this visible and clear to all? In chat window, kindly confirm. Anybody? Okay. Eclipse Mosquito. Is it audible and visible to all? For integration of MQTT broker. So you can see that this one is free and open source broker for IoT programming, for IoT interfacing. So you can see that for IoT, if we want to install it, we want to go for messaging with low powered sensors or mobile devices or phones or microcontrollers. So now what we will do, simply if I download this software, it is completely free and open source. If I download this software in my system, in my laptop, then my laptop will become MQTT broker. After that what I will do, from my mobile or from my laptop, I want to interact with my washing machine, with my AC, or with LED. So I will put settings, or I will put interfacing scenario with my smart LED, with my smart AC. Okay. So whatever credentials I am putting, I will put in settings of that particular AC. Those I will be able to communicate. Okay. So this thing I have defined here, I have mentioned here. In center point, we are having MQTT. This, it may be a laptop, it may be a system. Now this particular MQTT will be communicated with other devices. It will be communicating with other gadgets. Okay, for example LED or any other, and any number of devices can be attached. Some more platforms available. Okay, Hive MQ, hundreds of MQTT brokers available. So you can see that this one, integrate OT Hive MQ. And for corporate level, for industrial level IoT implementation. Okay, for example we want to implement it for manufacturing, energy, for automotive sector, for logistics. Okay, we want to control each and everything, we want to monitor each and every data, so stream IoT data in real time, so with Hive MQ. So what I will do, if I want to collect real time data from my LED, from my TV, from washing machine, AC, whatever it is, for streaming of IoT data, real time IoT data, I will download this software Hive MQ. So it's up to you whether you want to download Mosquito or Hive or any other. Okay. If I download this software in my mobile phone, in that case, my mobile will become MQTT broker. What is broker? Now we are using some particular terms, broker. What is the use of this particular term broker? In case of web based technology, you might have heard about one scenario that is known as client server architecture. In case of IoT, Internet of Things, we do not use the term client server architecture. We use this particular communication, broker client communication. Okay, task is same. In internet, in world wide web, in web technologies, we call as client server architecture. In case of IoT, we do not use the term client server, we use broker client. Okay, in whatever operation is performed by server in web technologies, same task is done with broker. So in IoT, whatever module or whatever device is providing service, that is known as broker. So if I want to control multiple devices, multiple gadgets from my laptop, in that case my laptop will become broker. In web technology we call it as web server, okay, or server. But in IoT we do not use the term server, we will use the term broker. My laptop is a broker, my mobile phone is a broker, and from my mobile phone I am interfacing with gadgets. From my mobile phone I want to communicate with my car or with my bike, so that bike will become client. Okay, bike, car, that is client, mobile is broker. So client broker communication. In case of web based technology, we do not use the term client broker, we use client server. Okay, so same thing here. So any of these software you will be able to download. Rabbit MQ is there. Okay, so thousands of platforms are available which you can use. So you can see that it is also freely available, free and open source. Rabbit MQ for real world data analytics. So you can see AMQP or MQTT 5.0. It is supporting open standard protocols, open standard IoT protocols for, you can see, streaming, real time streaming, IoT data, drone. So this is the scenario of drone. For example, multiple drones we are having, drone 1, drone 2. So these drones are interfacing with Rabbit MQ. That particular Rabbit MQ is controlled remotely from some particular device, or that rabbit MQ is installed in some base station. So while sitting in a base station, while sitting in a controller or controlling room or control room, we will be able to communicate with remote drones. Okay, in same way, if you are working on some scenario related to hospital management, so multiple patients are attached with sensors, temperature sensor, BP sensor, diabetic sensor, whatever it is. Okay, and those sensors are sending data to which, using which protocol they are sending data, using MQ. Okay, MQTT protocol with rabbit, hive, or with mosquito. Okay, with these they are streaming data, and in whatever system we have installed these software, we will be able to monitor these signals. Okay, and then we will be able to take preventive measures, we will be able to take suitable decisions. And you can see that many top level companies are using these software, Mercedes, so you can see that DKE and so many others for real world data analytics. So this one, so with hive MQ, so in Mercedes this particular protocol is used. You can see that Mercedes Benz enhances production qualities with hive MQ. Okay, many top level corporate giants are using MQTT protocol for communication, for manufacturing, for real world data analytics. And as a researcher, as a faculty, as a professor, as a mentor, we can use and we can suggest our students to work on these projects. Okay, so you can see that this one. Now we will see how to use these software, by which way to some extent we can have its demo. Okay, any of these software you will be able to download. So these scenarios I have mentioned in this presentation, by which way we will be able to work with it. Now there are two protocols, two major protocols, MQTT and COAP. Okay, constrained application protocol, or MQTT, which we use in IoT. Okay, now which protocol we have to use? If we want to work with many to many relationship, many to many, M2N, you can see that this one. Many to many means many devices with many gadgets. For example, FASTag. Okay, FASTags are provided by different companies, and toll plaza are also multiple, multiple toll plaza, multiple FASTag. So many to many relationship. In same way, different types of drones and different controllers. In that case, we can use many to many. But if we need high security, one to one relationship, for example, defense application, in defense application, in law enforcement agency, we want to propose this scenario. In that case, one to one relationship is required, COAP. For example, you are using some robot for defense, you are using some drone, so that particular drone should be monitored by your base station only, by your controller only, rather than anybody else. Okay, so in that particular scenario, we will use COAP. Otherwise, what will happen? If we have deployed a drone or robot, it can be controlled by anybody who is using MQTT protocol. So to avoid any interception, to avoid any intrusion, we can use COAP. But if we need a general implementation like smart city, okay, many to many like FASTag, I have just mentioned FASTag implementation. So in FASTag, for example, you are moving to from one place to another place. There are so many toll plaza. So in that case, we can't use COAP. If we will use COAP in FASTag, in that case, what will happen? Your FASTag will be monitored or accessed by particular toll plaza, because it is one to one. Okay, obviously it is not desirable and it is not feasible. Okay, because when we move to 500 or 1000 kilometers away, then 5 to 6 toll plaza are there in between. So multiple toll plaza and fast tag of different companies. Okay, whether you are taken from ABC Bank or XYZ Bank or from any other agency, so it should be identified. For that, we use MQTT protocol. So this thing should be clear for which application we have to use it. Now we will see by which way we can use these protocols, by which way we can create some scenarios, and with use of flow based programming platform. Okay, now I am covering about programming part. See this very carefully what I am doing. To work with programming part, what we will do, for example, we want to create a dashboard. In that particular dashboard, we want to link n number of gadgets, n number of devices, temperature sensor or LED or washing machine or whatever it is, or car or bike. In that case, we need a particular programming interface. Obviously, we need a particular scenario in which everything will be controlled. We will be having some push buttons, we will be having some particular links. On click of these links, some operation will be performed. Now, two more terms we will discuss here related to MQTT protocol. These will be used in demonstration. One is publish, second is subscribe. You can see publish, subscribe. In case of IoT MQTT communication, two terms are used, publish and subscribe. Now, if we relate it with classical web technology, in classical or traditional web technology, what we do, which two terms we use? We use the terms request response. So from my web browser, if I am opening a website, it means I am requesting something from server. Server is responding me. So in web technology, in World Wide Web, we use request response. In case of IoT, we do not use the term request response. We use publish subscribe. It means if one sensor is sending data, if one sensor is sending signals, it means it is publishing something to some other gadget. So publishing means sending something. Subscribing means accepting something, getting something. For example, we have one laptop. That particular laptop is receiving some message. It means it is subscribing. My mobile phone is getting SMS or WhatsApp message. It is subscription. Okay, subscribing. I am sending message from one gadget to other gadget in IoT. That is known as publishing. So publish, subscribe, it means send and receive. Okay, so these terms should be clear. These are very basic terms used in IoT programming, MQTT protocols, or any protocol. Now we will see using which software or using with which programming platform we can create some scenarios, some effective scenarios related to IoT. Lots of programming toolkits available. In programming toolkits, there are number of options available. You can see here I have given it. So this is MQTT protocol. So flow based programming, flowhub.io, no flow js. Okay, no flow js. You can see that flow based programming for IoT or any other scenario, we will be able to work with it. So this is known as flow based programming. Flow based programming means no need to write even a single line of code. Okay, without writing anything, without scripting anything, I want to perform my implementation. This is known as flow based programming or GUI programming interface. So you can see this one. So for example, this is my gadget 1, gadget 2, and by drag and drop we want to control these devices. Okay, so this one in same way we have number of other programming platforms. So Praxis Live, okay, Praxis Live is there. Either you can use NoFlow.js or you can work with Praxis Live. So this is also flow based programming platform. So in this way, so what we do, whatever scenario we want to implement, we create its only diagram. For example, I want to work on smart home automation, or I want to control multiple drones from my laptop or mobile. What I will do, I will create diagram of different drones. Okay, I will create only a flow chart. Flow charting we will perform using. So after creating that particular flow chart in this way, or or flow diagram, we will be able to control. So on right click stop, on right click move, or whatever it is, okay, whatever platform is giving that particular feature, we will be able to control. So if I right click some particular drone and click and perform some operation, that operation will be performed remotely. Okay, so many other platforms you can see that Netron. So this presentation I will share to all of you. Now I will cover that particular platform that is very easy to use, that is known as Node.js. So you can see that in Node, in NoFlow.js, this type of scenario we will be able to create. Okay, and number of sensors we are having, and those sensors we have created a diagram in a laptop. Okay, and whatever we will perform in this particular diagram in laptop, it will actually happen, it will actually be performed on physical devices. Okay, with MQTT protocol. So you can see in this way. Now I will show you one more platform that is very very powerful, and on that software I will perform the demonstration, that is known as NodeRed. Okay, NodeRed.org. Completely free and open source, low code programming platform for IoT based applications. When we discuss about programming part, many times participants or researchers or students think that they will have to learn Python or Java or Node-RED or Node.js, some particular programming language. But if we are working on low code programming platform, then no need to write even a single line of code. Without writing even a single line, we will be able to work with IoT scenario. So in this way, we will be able to create the diagram. I will show you its demo also. So where we can install this software. If you want to install it on laptop, you can work on it. If you are working on Raspberry Pi, BeagleBone Black, okay, you are working on Arduino board, Android. So you can see that if some of you might be working on some research projects on Raspberry Pi, on BeagleBone, on Arduino. So you can integrate, you can install this software on open source hardware. Okay, Node-RED, completely free and open source. If you don't want to install anything on local system, you want to work on cloud. What is use of cloud? One very simple scenario I am discussing. For example, I want to communicate with my TV, with my mobile phone, okay, with MQTT. In that case, definitely, for example, I have installed MQTT in my mobile or MQTT in my laptop. With laptop I will be able to communicate with my TV, okay, via MQTT interfacing, but in a wireless range, in Bluetooth, infrared, or whatever we are using. I want to control my device, my appliance from 500 kilometers away. I want to use remote, my TV remote from 100 kilometers away from other city. Currently, it is not possible. Okay, because TV remote is having a range. Okay, 50 meter or 100 meter depending upon different companies. But I want to use my TV remote from other city or from 1000, 5000 kilometers away. In that case, what we have to do? We have to put that platform MQTT on cloud. If we work on MQTT on cloud, in that case we will be communicating with our appliances via internet, and internet is everywhere. Okay, whether you are 5000 kilometers away or 5 kilometers away, internet is available everywhere. Okay, so for those applications we work with this particular scenario, Microsoft Azure. So if we want to control our appliances, for example, you want to switch on or switch off your AC from other city, in that case you will have to move to cloud. Your AC should be connected to cloud, your MQTT should be connected to cloud, and your NodeRed should also be connected to cloud. It means everything should be on cloud. But if you want to work in a controlled environment means private personal environment, like within 50-meter range. Otherwise there may be problems of sniffing, there may be problem of cyber attack. Okay, or just for demonstration you want to work smart home automation, obviously in a limited, in a controlled environment we want to use. So for that we can use Raspberry Pi, Arduino, Android. But after installation on Raspberry Pi with ESP chip, with ESP sensors, we will be able to connect with Bluetooth, or we will be able to connect with wireless technology, with internet. Okay, so it's up to you whether you want to work on local or you want to work on cloud for remote monitoring. Now we will see how to work on this particular platform, NodeRed. To work with this particular scenario, I am opening one cloud platform, that is Replit. This is very powerful platform for hosting of NodeRed services. Okay, so I am opening this one. I will open this. So I am already using it on cloud. Okay, otherwise you might have seen that if I want to work with Raspberry Pi, definitely I will have to purchase Raspberry Pi. If I want to work on Arduino, we will have to purchase. I don't want to purchase anything. Okay, as a researcher, as a mentor, as a teacher, we want to use for some research projects. Okay, otherwise each and every sensor we will have to purchase, each and every gadget we will have to purchase now. But we don't want to purchase anything, we want to work on cloud. So this is cloud variant. Now you can see that this NodeRed is running, and we will execute it. Now you can see this is NodeRed interface, flow based programming for IoT. This one, now you can see that this is working panel. This one is the working panel. Okay, now you can see on this working panel, I will simply design a flow chart. I will not write even a single line of code. If I want to work with some gadget, you can see that MQTT is available, MQTT in, MQTT out. I want to work with WebSocket, so simply drag and drop. You can see that it's as simple as paintbrush. Okay, I want to work with MQTT, drag and drop. Okay, what I need, simply drag, and after dragging it we will go for some connections. Okay, so I will create one diagram from very scratch so that you will be able to see its demonstration. Okay, so inject means initiate communication. So on mouse over you can see it is giving me message, this particular tooltip, that for which purpose it is available. So simply drag. So you can see that I am not writing any code. Double click, initiate IoT communication, done. Now you can see this particular block. So as simple as paintbrush, as simple as as MS Word. No need of any writing, any code writing. Okay, no code, without using any code, without using any scripting. If I want to use some function, you can see functions which, if I want to integrate WhatsApp, I want to integrate Telegram, open weather map, everything is available. I want to integrate satellites, that is also available, we will be able to customize it. Okay, now MQTT, this I want to integrate it with MQTT. Okay, or before MQTT I want to show a very small demonstration like uh, device interfacing. So you can see that output console. Okay, after that I will show you MQTT output. Done. Simply connect it. A- as simple as paintbrush. Okay, now you can see that this connection is available. Now I will deploy at top right, deploy. As soon as I will click here, initiate communication, I will receive message here at right hand side. Click. Now you can see that this one. Okay, now I want to communicate, I want to integrate this particular message, this particular block with MQTT. So you can see that MQTT out. I want to send this particular message to some devices. For example, this is my AC. Okay, one more. This one is vehicle GPS. Done. Simply connect. So currently I'm working on simulation part, but if we are actually having some smart AC, some smart vehicle, some smart LED, then that setting will be able to put. Now I will put some settings from cloud. Which cloud I will use? I will use this particular cloud, test client. So this is MQTT client. All of these are online available for research and development. Okay, for a search based application. For example, this is car. Okay, this is car subscription. So in my presentation I have shown you what is meaning of subscription. Subscription means I want to accept data, some data car want to accept, some signals AC want to accept. Okay, so we are creating two interfaces, one for AC, one for car. Okay, it means car will receive some signals, AC will receive some signals. Okay, so whatever message I will send from this dashboard, it will be received here. You will see that these are two different windows, two different URLs. Okay, into different tabs I'm showing you. So whatever message I will send from here, it will be received here in AC or in car. Okay, if we are actually using some AC, car, washing machine, in that case that message will be sent and appropriate action will be taken. Now in AC, add MQTT broker. Which broker I want to add? So this is the broker, MQTT. This one 1883 is the port number, this 1883 port number, and you can see that this one, and so this is which protocol we are using, MQTT 3.1 or MQTT version 5 or whatever it is. Okay, now security. If we have secured this particular device, for example our AC is secured, definitely it should be secured. Our washing machine, our refrigerator, these are having some password, username, password, otherwise anybody will be able to switch on or off. If I have not given security to my AC washing machine, then anybody from mobile phone or by hacking they will be able to do anything with our home appliances. So if we have given some security, we can give username and password. Okay, so that it will be authenticated. Now add. Okay, done. Topic, which topic? So this is your car AC. So this is same topic we have given here, AC. Okay, now done. For GPS we are taking this one, topic is car, and done. Now I will click here on deploy. I will click here and this message will be received here. Okay, these messages you will see as soon as I will click from different window, from different tab. So deploy. Now you can see it is showing connected. Click. So I will click here and in this tab you can see that topic car, topic AC, this one. Okay, so on second click we are getting some signals. Okay, topic car, in which particular signals we are receiving, If you want to put some particular message, some specific message like on, off, shut down, initiate, that can be done. Okay, if you want to put some specific message, some specific signal, if you want to write this particular output in a text file, you can see write in a file, read file. Okay, so status, what is the status of all, and click. Now these signals will be received here. Okay, so whatever, as soon as we have clicked, it is identified by test client, and we will be able to monitor it. Okay, now if we want to add some extra blocks, for example, we want to add weather forecasting, we want to add some particular, if we are working on some agriculture project, then we want to add some blocks. So you can see that this one, manage palette. On click of manage palette, you will see so many blocks, more than 5,000 blocks. Now I want to work for weather. Okay, you can see that node country weather. Okay, so open weather map. If I want to work with WhatsApp, if I want that each and every message should be received on WhatsApp, so you can see WhatsApp link, WhatsApp media. Okay, so whatever operation is going on in this particular panel, same message we want to receive by SMS, by WhatsApp. Okay, whether it is related to weather forecasting or anything else. Okay, so some scenario, so each and every link I have given in this presentation, so that you will be able to work on it. Okay, so in this way, so I'm showing you that particular part. Now if we want to create some particular scenario, some particular condition, so this one, so some scripts I have already created. Now I want to import some particular scenario. So this diagram I'm placing. So you can see that this one is the scenario. Now import whatever script we are having. For example, one script we have already created related to a diagram. Battery MQTT import. Okay, now you can see that this one, click. Depending upon some conditions. Okay, so battery, so for example you want to see what about current battery level, current power level. For example, in your car you have integrated it. Now nowadays you might have seen that electric vehicles are there. So we want to see at which particular time battery is less than 20%, or battery or that particular remaining power is less than 30%. Okay, so check battery level, battery of car, electric vehicle. So in this way we can create a diagram. So we have created a particular diagram. Check battery level. So from where this battery level is coming, so from this one, this is switch statement in C++, in Python, in Java. You might have seen we use some switch statements, but here we don't need to write any code for switch statement, switch case 1, case 2. No need to do that. Simply drag and drop. This is a switch, which are three conditions of switch: case 1, case 2, case 3. High battery, low battery, and this one. So this one is broker and phone battery or vehicle battery. So deploy, and now you can see it is connected, and whatever message we want to receive, it will be received. Okay, that particular signal we will be able to receive. So in, you can see that this one. Okay, deploy, and at right hand side we will be able to see that particular signal set. And so in phone battery, so for example some particular signal in this way. Okay, so from any panel you will be able to send a specific signal. Some you can send some specific data. Okay, if you want to control this particular scenario with command prompt, for example, with command, you want to send some specific signals. So for that, so all of these scenarios I have already created. For example, we want to create it a particular Python code with Python script. We want to control a specific scenario. So you can see that this one, and on desktop now this one. Okay, now in this particular script, so this is simulator, so topic is gk, so I'm taking this particular, subscribing this topic gk, so that we will be able to send some data. Okay, broker.mqtt.cool, uh, temperature, and now we want to execute it. Okay, so you can see that sending this particular data, so you can see that at one point we are sending data here, and here we are receiving same particular output. So you can see that with script, so sending 30.54 received here. So in same way, if I want to receive, for example, this is for ev, okay, electric vehicle. Okay, so subscribe. In this particular code, we are giving that particular topic. This is mq, so either by python or by any other platform you will be able to work with it. So now you can see that in electric vehicle we are sending this data. So 28.16, now 26.22. So in real time it is getting this particular signals. Okay, so in this way, very realistic projects we will be able to work out with smart devices. Okay, whatever data we are sending, it is getting received here at right hand side. So if I put control c, now it is stopped. Okay, now for example, from scratch we want to see, so now it is clear. Okay, now from scratch we want to send some signals. Enter. So you can see in electric vehicle, so whatever data we are sending from our device, from our broker, so this is mqtt. Okay, so in same way, for example, so if I so now I am showing you that particular script. So in this script, what we have done, so I'm showing you in this format so that you will be able to view it. So this is script. Okay, so what we have done in this python script, broker.mqtt.cool, this is same, 1883 is the port number. Electric vehicle is your topic that we have already subscribed. Okay, and then we are sending some data. Either you can work it with python if you are comfortable in python programming or programming interfaces. If you don't want to work in coding part, okay, then you can work on this particular implementation on this type of scenario. Okay, for example, so no need to write any script, simply drag and drop, and then you will be able to communicate. So deploy. Now you can see that as soon as I will click here, this message will be received. So you can see that now it is under topic car and AC. So one more topic I am taking here, for example, this one. Okay, so multiple gadgets, and now we are interfacing. So without any coding, without any programming part, simply create diagram and rest it will do automatically. Now you can see that now I will, as soon as I will click deploy, now this message will be received here. Okay, now click, instantly these messages are received on this test client. Okay, this is test client, but if we are having actual gadgets, we are having actual devices, sensors, then this particular data will be moved. If you want to put some delay, for example, we want to give some particular time gap, some delay, so that can also be done. Okay, so for example, I want to put a delay of how much time, for example 5 seconds. Okay, delay. Okay, so now first of all it will move to delay, and as soon as I will click, after 5 seconds this operation will be performed. Now deploy, and one response will be received instantly after, then next after 5 seconds. Okay, now you can see after 5 seconds next message is received in AC. Why? Because we have put one delay, this one. So in this way you will be able to work with very effective implementations without any coding. If you are comfortable in programming part, then you can go for Python code. Okay, so this is flow based programming that you can integrate, and these screenshots I have given in this presentation so that you will be able to work on it. Okay, so you can see that this one. So any of these platform you can use. If you want to use cloud of Hive, that is also available. Okay, Hive MQ cloud. Okay, its free cloud is available. So fully managed server. Okay, so in free variant you will be able to put 100 connections. So if you are a researcher, if you are if you want to take that 100 connection, or you want to work up to 100 connections, so you can work in free variant. Okay, no need to link your credit card. So you can see, either you can use HiveMQ or MQTT, this broker. Okay, for 100 connections it is completely free. No need to link your payment gateway, payment credentials, or payment mode. Basic MQTT for learning and experiment. Okay, for if you are doing some research work, some research project, for that you need, so actually 100 connections are more than sufficient. Generally we work with 5 to 6 or 10 connections. So up to 100 gadgets you will be able to communicate. Now, dear participants, I am sharing this presentation to all of you. This particular presentation, which I have created, in which every screenshot is available, I am sharing to all participants. If you have any query, you can ask. Meanwhile, I am uploading this presentation. Okay, so this one.